Hello viewers, welcome to this video. Right, a few of you asked me to do a video on how to rotate or renew Kubernetes certificates, and I've been wanting to do this video for a very long time. I should have done this long time ago, but I don't know how I missed this one. I thought I actually did this video, but I searched in my playlist in my channel. I couldn't find one, so probably I didn't do it. So here it is, and let's see how to renew Kubernetes certs. By the way, this process is based on Kubernetes cluster that are provisioned using Kubeadm tool. Okay, so if you have provisioned your cluster manually following the Kubernetes, the hardware or something like that, the process I'm going to show you is not going to be applicable for you. This is purely for Kubeadm managed, Kubeadm provisioned cluster. Okay, let's get started. I'm in my play directory and I'm going to git clone my Kubernetes repository. I'll put a link to my GitHub repository in the video description. And I'm going to go into Kubernetes and Vagrant provisioning. So this is where I've got my Vagrant file. And when I do Vagrant up, it's going to be using VirtualBox as the provider. But in my case, I want to use libvirt as the provider. So let's bring up the Kubernetes cluster. It's going to take a few minutes. It will bring up a master and 2 worker nodes. I think it will provision Kubernetes 1.22, I think. Right, I'm going to pause the video and come back when the cluster has been provisioned. Alright, Vagrant up command complete. Now I'm going to make a directory .kube under my home directory, and that is where I'm going to copy my kube config file. So there is a scp command that I'm going to use, root at 172.16.1600, which is my kmaster, the master machine, and I'm going to copy etc kubernetes admin.conf. That's the cluster admin's kube config file that contains the certificate and the private key required to connect to the API server, and I'm going to copy that to .kube directory as config. And the password is Kubeadm if you're using my Vagrant environment. Alright, now I can do kubectl cluster info. So that's our cluster, kubectl get nodes. Yes, we are using version 1.22. 1 master, 2 worker nodes. They are all Ubuntu 20.04 machines running containerd version 1.5.5. Okay, so we've got a working Kubernetes cluster. I'm going to split the pane and I'm going to log into the master machine, root at 172.16.1600. Password is Kubeadm. Alright, so I'm going to show you the kube init log. If you're not following my Vagrant provisioning method, if you have done Kubeadm init yourself, you would have seen the output of the Kubeadm init command. In my Vagrant environment, I captured that in a log file in the root directory. So if I do root kubeinit.log, I wanted to show you the phase where it generates all the required certificates. Okay, and it generates a bunch of certificates. So it first generates the certificate authority, the certificate and key pair for the internal root CA, and then it goes ahead and creates the certificate and key pair for other components, and then gets those certificates signed by the internal CA, and it has got the separate internal certificate authority for HCD and also for the front-end proxy CA for the kube proxy. Okay, so we have these set of certificates created by Kubeadm. So Kubeadm tool generated these certificate and key pairs, and it's going to manage them for you. And we should be able to use Kubeadm tool to renew certificate, to check the certificate validity, and so on. Okay, so if I go into etc Kubernetes, right, so we have configuration files where we have the certificate and the private key embedded within these configuration files. So this admin.conf is, as you know, is the cluster admin's kube config file. And then this is the configuration file used by the controller manager component. This one is used by the scheduler, and this one is used by the kubelet. If I take a look at one of those, for example, admin.conf, you see the encoded format, encoded version of the certificate authority's certificate. And if I scroll further down, so we have the encoded certificate and the encoded private key for the user Kubernetes admin. So that's going to be the same for the other configurations. So if I show you the controller manager, again, the encoded version of the CA certificate. And if I scroll down, you have the encoded version of the certificate and the key pair for the kube controller manager. And again, it's going to be the same for scheduler and kubelet. Yep, encoded certificate for CA, then the encoded certificate and the private key for kube scheduler components, again going to be the same for the kubelet config. So these are the list of configurations that contain the certificate and the private key data embedded into the configuration file so that these components can talk to the API server. Okay, and there is another directory here which is pki. Right, I'm gonna install a package called tree so that I can easily show you the list of files here. Okay, if I do tree dot, right, you can see here there is this API server certificate and the private key for the API server. So that's the private key and that's the certificate for the API server. And then we have the certificate and the private key pair that API server uses to connect to HCD. Again, the certificate and private key pair that API server uses to access kubelet. And then this is the internal root CA certificate and key. And if you look in the HCD has got its own internal certificate authority, and all these certificates will be signed by this HCD's certificate authority. And then we have a separate certificate authority for the front proxy used by Kube proxy. And then we have the certificate and key for a service account. So that's the list of files. And if I do, and all these files were generated by Kubeadm when I ran it at 1610. Okay, and if I go one directory above, star.conf, again around the same time 1611, and all these configurations, all these files were created by the Kubeadm. Okay, now let me show you, there's a Kubeadm subcommand that you can use to check the certificate status, certificate validity, expiry status of your cluster, the different certificates used in your cluster. So if I do Kubeadm, don't confuse with kubectl, it's Kubeadm component, Kubeadm search, and if I do --help, you've got all these subcommands: certificate key that generates certificate keys, check expiration, which we'll be using, and then renew to renew certificates for certain components or for all the components, which we will see in a short while. If I do Kubeadm search check expiration, okay, you can see the list of certificates. It normally contains the certificates. This one, for example, is a configuration file. This one, controller manager, we saw it under etc Kubernetes, but this configuration file contains the data, the encoded version of the certificate and the key pair within them. So it's all listed here. And as I said, we've got 3 different certificate authorities. So that's the base or common root certificate authority. This one is HCD specific certificate authority, and this one is for the front proxy certificate authority. And here you can see which certificates are signed by which certificate authority, and you can also see whether these certificates are managed externally or internally. And the other thing you can see here is the expiry date, November 27, 2022, 1611, which is exactly a year from now, 364 days, and it's basically usually Kubeadm, when it generates a certificate, it is valid for like 12 months, and now it's 1622 and we generated these certificates at 1611, and it will be expiring in 12 months time. We have the renew command, Kubeadm search renew, and you have to pass in the option. You can individually renew certificate for different components. For example, if I want, I can just renew the certificate used for API server or HCD or scheduler, controller manager, or the Kubeadm. Or you can also renew the certificates for all the certificates used in your cluster. So if I do --help, you have this option. Available commands, so Kubeadm search renew admin.conf, for example, to renew the kubeconfig file for the cluster admin. API server, you can target the individual components, or you can just pass all. Let me show you just one component, the API server. Let me just renew the certificate for the API server. If I do check expiration, make a note of all these timestamps, the expiry date. The other way to check the expiration is the API server. I've got a bit of lengthy command to check the expiration date of the certificate. Okay, so the command is this. I'm using OpenSSL s_client subcommand show certs, and I'm connecting to 172.16.1600 on port 6443, which is the port API server is listening on. And this IP address is the IP address of the K-master. Server name is API, so that's going to spit out the certificate to the std out, the standard out. And I'm using another OpenSSL command to grab the expiry date of the certificate. Okay. If I do kubectl cluster info, you will see the cluster endpoint here. So that's what I've used in my OpenSSL command. you echo the command not after the certificate is expiring on the 27th of November 2022 16:10:59, which corresponds to, so this is the certificate detail for the API server. So if I look in the API server here, it's 27th of November 2022 16:10, which is same as here 16:10. Okay, what if I want to renew the certificate just for the API server component? Let's do it. Kubeadm search renew API server. Alright, certificates for serving the Kubernetes API renewed, and if I do check expiration, and you can see the API server is now at 16:25. If I do this command again, you still see that it's the certificate that I'm getting by connecting to the API server is still showing that the expiry is at 16:10, which is the old certificate. The thing to note here is, so we have generated a new certificate for the API server component, but we have updated the files, the certificate files in the file system, but we haven't actually restarted the API server component. So you also need to restart. It's not actually required. So if I run this after a short while, maybe a few seconds have passed, and if I run the same command again, now you can see it's pulling the new certificate with the right expiry date. So all I'm doing with this command is I'm connecting to a HTTPS endpoint. I'm downloading the certificate and checking the end date, the expiry date of the certificate. Previously, after generating the certificate, it was showing the old certificate expiry for a short while, and then after a while I didn't have to restart the API server, but I get the new certificate now. So now I can confirm that the API server is serving on the new certificate. Now I can confirm that the expiry date is 16:25, which is same as here 16:25. But it's always a good practice to restart the component. So for example, if you're renewing the certificate for the controller manager, just restart the controller manager component and things like that. So in our case now, although it's looking fine, I would advise you to restart your API server. When you restart your API server, there will be a very brief downtime if you're running on a single master cluster. If you've got multiple master, you don't have to worry about it. You need to do this on every single master. So I forgot to mention that it's always a good practice to back up your certificates before you generate a new one. It won't go wrong, it can't go wrong, it's a simple mechanism. So I would do something like make directory kube backup or something, and then copy, preserve the permission, etc kubernetes star.conf to root kube backup, and also preserve the permission, copy recursively etc kubernetes pki again in this place, and if I cd to that directory and to, yeah, we have the different Kubernetes configuration file used by the different components, and also pki, and we have pki all the different certificates and also the etcd. So I would just do a quick backup on all the master nodes. If you're running on multiple master setup, just a quick backup for peace of mind. Alright, going back to etc kubernetes, and let's go to the pki directory, and if I do ls-latr, you could see the certificate and key pair for the API server component got generated or recreated at 16:25. So that's when the certificate is expiring on 2022. Still, we haven't restarted our Kube API server, which is always a good practice to restart once you renew the certificate so that the process uses the latest certificate. Okay, so before restarting that, anyways, I'm going to renew all the components. So let's do Kubeadm search check expiration. Okay, I'm going to do Kubeadm search renew all. So I want to show you how to restart those master plane component, the control plane components, but before that, let me renew, just in case, let me just renew all the components. Kubeadm search renew all. Alright, so it's going one by one each component, and then it generates the certificate for all of them. And you also get a nice message saying you must restart the Kube API server, controller manager, Kube scheduler, and etcd so that they can use the new certificates. So if I run the echo statement again connecting to the API server, let's see what it has now. Alright, I think it has already updated serving on the new certificate 1629, and on the top here, if I do check expiration, you can see all the components have been updated with the certificate, and now the expiry date is like 16/29, 16/30. Right, all looks good. Now we need to make sure to restart the API server, control manager, scheduler, and etcd. The way to do is, because these are static pods, you can't just kubectl delete those pods. If I do kubectl -n kube system get pods, well, you can see there is the etcd pod, Kube API server pod, controller manager pod, scheduler pod. So these are static pods. You can't just do kubectl delete pod. It won't actually work in most cases. So the way to do is log into each of the master node one by one if you've got multi master node setup. And here, because I'm using containerd, there is a command crictl that gets installed when I install the containerd. But if you're still using Docker as the container runtime, then you could use just Docker remove that particular container. For example, API server, find the API server container, Docker ps grep for Kube API server, and then remove that container, wait for it to restart, and then go with controller manager, scheduler, and etcd finally. In my case, I'm using containerd, so I've got a tool called crictl. I need to pass the containerd socket as the runtime endpoint in the format Unix // run, I think it's var run containerd container.sock, and if I do ps crictl, not critctl, it's crictl, pass in the runtime endpoint, which is the containerd socket, and I'm doing ps. It's similar to Docker ps, and that's the list of container, and I can do pods. Right, so those are the list of pods, and I don't have to pass in the -r option to every single crictl command. I can export a variable called container runtime endpoint equals, let's copy this one. Alright, so now I can do crictl ps crictl pods, and it should all work. And now you can see the list of pods here. So we have the Kube API server, we have the scheduler, we have the controller manager, and the etcd kmaster. First, let's restart the Kube API server. Okay, so there are a couple of ways. You could just stop. Let me show you. crictl, and there is a command to stop the pod. So rmp is remove one or more pods. Let's try that. crictl pods, crictl remove pod. Kube API server's pod ID is this one. And if I try to remove the pod, it says the pod is in a running state. You need to stop the pod first before trying to remove it. Okay, let's do that. crictl stop will stop the container, but stop p, which is basically stop pod, is going to stop all the containers running inside the pod. So crictl stop p, the pod ID, and I'm also going to remove the pod. Okay, so pod stopped and also removed. Now if I do crictl pods, already see Kube API, so that's the new pod that was started like 4 seconds ago, 12 seconds ago, and rest of them are like 22 minutes, 23 minutes ago. So definitely we have restarted our Kube API server. Alright, crictl pods, let's do the same thing. Now I want to show you the other way. Right, so I'm inside the pki directory. If I go to etc Kubernetes manifests directory, so this is where all the static pod manifests are stored. We have our API server, controller manager, scheduler, and etcd. These are all static pods, which means if you just delete a file here, kubelet will delete that pod from your cluster. Alright, the simple hack is to move this file temporarily out of this directory and wait for the kubelet to delete the pod, and then move it back here, so the kubelet will again start the pod. So this is like restarting your pod. Alright, we've already done the Kube API server. Now I'm going to move Kube controller manager to /temp, for example. Okay, that's done. And if I do crictl pods, you see the controller manager is not ready. I can do crictl remove pod, because anyway it's not running, I can remove it. The pod ID is this one. So that's gone, and I'm going to move that manifest back to etc Kubernetes manifests directory. And if I do crictl pods now, there we go, Kube controller manager started 3 seconds ago. Right, crictl pods. Now let's move the scheduler to /temp CRI/CTL pods. Yes, Kube scheduler has gone to not ready state. I'm gonna copy that pod ID. CRI/CTL remove pod. Not found. That's not the right one, I guess. Let's check. CRI/CTL pods. That's already gone. Okay, so now I can move Kube scheduler manifest back into etc Kubernetes manifests, and that should have. So now kubelet should have found that there was a new file in the etc Kubernetes manifest directory, and it should have started that new container for Kube scheduler. And there we go, Kube scheduler started 10 seconds ago. Right, so we have restarted the Kube API server, controller manager, scheduler, and the final thing is the etcd. Right, move etcd.yaml to temp CRI/CTL pods. Okay, etcd kmaster not ready. Copy CRI/CTL remove pod. Right, that's gone. CRI/CTL pods. Clearly we don't have any etcd container running in my kmaster. Move temp etcd back into etcd Kubernetes manifest directory. Kubelet should now find it and start a new etcd pod. Let's see. CRI/CTL pods. Yep, etcd kmaster 2 seconds ago, but allow a little bit of time for etcd to settle down, maybe like 10-15 seconds. Alright, 26 seconds ago, and if I try and get the cluster info, yep, our cluster is still up and running. kubectl get nodes, everything is good. kubectl -n kube system get pods. Right, so you can see this was started 64 seconds ago. Alright, so that's how I normally rotate or renew the cluster certificates. And the other thing to note is if you are upgrading your Kubernetes cluster, Kubeadm upgrade plan, Kubeadm upgrade apply, these certificates will get renewed automatically, so you don't have to think about renewing the certificate yourself. That's it. Hope you found this video useful. Let me know if you've got any questions. I will be happy to help, and I will see you all in my next video. Until then, keep learning and keep on learning. Bye bye.